So in today's video, I'm going to make really what should be called a beginner's video. This is one of the first things that you learn if you've ever been to electronics school, at least back in the day, and you took like a test instrument course. What you would do, you would learn to compensate your oscilloscope probe. So basically what I'm going to do today is match the scope to the probe input, and the adjustment I'm going to make is right here. There's a little trimmer capacitor in there, and if we look at this, the actual probe body here, we can see here it's got a, I don't know if I can show this close enough, it's got here a times 10 function and a times 1 function. The time 10 function, of course, that means that the signal strength, the amplitude, is reduced by a factor of 10, of course, when you have it in this position. This probe body here, when you put it in times 10 position, it has a built-in parallel resistor and capacitor combination. So what we're going to do basically, or rather, in order to do the compensation, we need a square wave, and either we can get that from the, oh, this camera's out of focus again, I hate that. Either we can use the square wave from the oscilloscope if it has it, or we can use an external square wave generator if that puts out a good square wave. And like, I'm going to use 1,000 hertz, and what we need to do is we need to put the probe in the times 10 position, and I set the display to show about 2 cycles, and then I adjust the trimmer capacitor. Of course, the hookup then is like this. We simply take the 2 grounds, put them together, and we take the end here from the signal generator, or rather the square wave generator, part of the signal generator or function generator, whatever you want to call it, and we connect it to the scope probe. This is a probe I worked on the other day. There was something wrong with it. Yeah, it was a bad ground cable. Again, so I put this in the times 10 position, and then we'll take a look at the scope right now. So here's the view of the scope, the display, and again, I like to set it up so I get about 2 square waves on there. And now I'm going to go ahead and try to make that adjustment with, I got a little screwdriver here, and adjust that little trimmer capacitor while holding the camera. I apologize for the shaking. I'm not going through alcohol withdrawal or anything like that. So I'm going to go ahead and turn that. Also, right here, what we're looking at now is what you would call overcompensation. See here, it's supposed to be flat, but it's not. Instead, we got at the front end here, we got a sharp rise, and then it's coming back down. And of course, undercompensation would be the exact opposite. This would be, this front end here would be more like slope down. I don't know if I can even show that. Let me try to go ahead and make that adjustment real quick like. And we can see that, there we go. Now that's how it's supposed to be, just like this. You'll find that you occasionally have to do this, or rather should rather quite often. If not, when you make measurements, you're going to be like you can be really thrown off. Let me just, now this here is, for example, that's what I was talking about. This is undercompensation. That's what you don't want either. We want a perfectly a perfect flat top here, if we can get it, and that's what we got right there. And here's another one I'm going to do. This is also a times 1 times 10 probe, and you can see here this has got a little trimmer box here on the end, and here you can clearly see the trimmer capacitor, and it's not too much in there really. I think there's like 3 resistors and the total of 2 capacitors. One of course is a adjustable capacitor. So I'm going to go ahead and basically do the same thing now. And here's the actual body of the probe. I've got it in a ×10 position now, and again I'm going to be using that 1000 hertz square wave, and I'm going to go ahead and make the adjustment. Here's the display, and again I adjust it so I get 2 cycles on here, and with the vertical settings you just got to play around with it to whatever basically suits you. So I'm going to go ahead and try to get the screwdriver in there, which is, I see, is not going to be that easy. And now something should happen now when I'm turning. Why is there nothing happening? Okay, there it goes. See here again? Overcompensated. Really overcompensated now. And going the opposite way, undercompensated, and going right about there. That's about correct. I got to do a little bit after adjusting once I shut the camera off, but that's how it's done. So there's just one more thing I want to point out real quick. I'm feeding in a 500,000 hertz square wave, which you're probably never going to be using for audio work anyway, so, but this is just to make a point. I'm in the ×1 position now, and if we take a look at the square wave, we can see the rounding off here. And now let me go ahead and put it for comparison in the ×10 position. Again, I'm shaking a little bit because I'm holding it, but you notice this square wave is a lot better. It's a lot more truer representation. But that's because if we use the ×10 position, we get a wider bandwidth and we get less circuit loading. But the advantage, of course, of the ×1 probe is you can see stuff that has lower amplitude. So it's kind of like basically a judgment call when you use what, but this is something you just have to keep in mind. I think that's basically all I want to say for now about this subject. I don't want to get too long, and there's probably videos out there that are much better than mine, or much more in-depth, or yeah, whatever. Anyways, thanks for watching.